One breath. Inside an unprepared industrial storage tank, that is all it takes to lose consciousness. The danger here is immediate and entirely invisible. We are dealing with confined spaces. By definition, these are areas not designed for continuous human occupancy. Structures with limited entry and exit points, such as manholes, underground vaults, agricultural silos, and chemical tanks. Because the margins for error are non-existent, navigating these sites require absolute adherence to the law. The procedures we are outlining are based directly on Singapore Workplace Safety and Health, or WSH, regulations and approved codes of practice. Before you even approach the entrance, 3 baseline requirements must be met. First, a fully approved permit to work must be issued. Second, you need a recently calibrated 4-gas detector. And third, every entrant must be wearing a full-body harness. But having the right gear is just basic compliance. Surviving a confined space means taking active control of the environment. You have to eliminate the variables before anyone crosses the threshold, and you do that by executing a strict 4-step sequence. There is a sobering statistic in industrial safety. Roughly 60% of all confined space fatalities are actually coworkers who enter the space attempting to rescue the initial victim. This diagram shows exactly why the air inside is so deceptive. Look at this cross-section of a storage tank. Toxic gases do not mix evenly. They separate by weight. Heavy, lethal gases like hydrogen sulfide pool directly at the bottom, while lighter gases gather at the top, silently displacing the breathable oxygen. If you only hold a monitor near the top hatch, you get a completely false reading. WSH regulations require you to use a gas monitor equipped with a drop probe. You lower that line to test 3 distinct zones, the top, the middle, and the bottom, allowing the sensor adequate time to register the air quality at each level. Once you map the atmosphere, you must force the hazards out. This requires setting up continuous mechanical ventilation. You use industrial blowers to push fresh air in, or exhaust systems to pull hazardous air out. And these machines must run before and during the entire operation. Systematic mechanical ventilation, verified by rigorous multi-level gas trusting, is the only empirical way to guarantee a breathable atmosphere before a manager signs off on the permit to work. With the air cleared, you have to account for what you are carrying inside. Often, a severe hazard is brought right in through standard power tools. This flowchart illustrates the physical mechanics of an electrocution. If you bring a standard 230-volt cable drill into a confined space made of highly conductive metal or one with wet surfaces, a single frayed wire touching the tank wall instantly creates a closed-loop electrical circuit, using the worker's body as the ground. The primary solution mandated here is complete removal of the hazard. You replace all 230-volt equipment with battery-operated, cordless alternatives. If the scope of the job strictly requires corded tools, you drop the power level. You utilize 110-volt tools powered by a center-tapped transformer, and you position that transformer completely outside the confined space. Controlling the voltage limits and physically isolating the power source is the definitive method to prevent catastrophic electrocution inside highly conductive vessels. Imagine working deep inside a structure when a sudden chemical reaction causes a gas leak. You collapse. If nobody is monitoring the entrance, you are entirely cut off from help. This is why regulations mandate a dedicated confined space attendant. They stand stationed directly at the entrance, equipped with the active permit to work clipboard, a continuous gas monitor, and a 2-way radio. Their duties are absolute. They act as the lifeline to the outside world, maintaining constant visual or radio contact with the entrance, and closely tracking the active gas readings from the opening. The attendant is bound by one operational rule. They must never, under any circumstances, leave their post or enter the confined space themselves. A disciplined, stationary attendant provides the singular anchor ensuring that an isolated internal incident triggers an immediate, coordinated response, rather than quietly escalating. History documents exactly what happens when procedure is ignored. In a Singapore Ministry of Manpower case study, a worker collapsed from sudden hydrogen sulfide exposure. Seeing him fall, 2 co-workers rushed in to pull him out. All 3 died inside the tank. The impulse to save a team member is a psychological trap. Entering a toxic environment without a self-contained airline respirator is mathematically fatal. You breathe the exact same air, and you become a victim. To eliminate this trap, you execute a non-entry rescue plan. Before the first worker even crosses the entry plane, you rig a mechanical tripod and a winch system directly over the opening, attached securely to the entrance full-body harness. Let's run through the checklist. 1. Secure an approved permit to work. 2. Run continuous mechanical ventilation. 3. Test the air across 3 distinct levels with a drop probe. 4. Ban 230-volt tools in favor of battery alternatives. 5. Post a stationary confined space attendant. 6. Ensure entrants wear a full-body harness. 7. Strictly ban impulsive, unprotected entry. And 8. Rig a mechanical winch system for external rescue. Share this specific sequence with your team. Review your site's current protocols and update them to ensure you are actively preventing casualties. Workplace safety is a deliberate, methodical choice. Applying these rigid controls to every confined space operation ensures every worker goes home safe.